Good morning, everyone. Good morning, Franco, which is probably napping. Good morning, Johnny. Good morning, Gerald. Franco, Johnny, and Gerald. How are you guys? My back is, fragile, but it's so far so good. It's not, hasn't exploded, which is good. How are you? How's everyone? Hope everyone is good. What was I looking through this for yesterday? I don't remember. Oh yeah, now I remember. I've got a project in mind, which we might be able to do a PCB for today. We need to prototype it. So get this. Actually, you know what? This needs a little bit of preamble. Let me open this up. All right. So on Amazon, you can buy these very inexpensive hydroponic grow kits. So you can grow like plants indoors in the winter. Big problem in Canada, right? It gets cold. Our growing season is fairly short. But they've made these hydroponic kits, which they're really inexpensive. All they have is a grow light. Oh, sorry about that, Johnny. How's it going, MT? So all it is a grow light. It's these baskets. There we go. These baskets and a big reservoir, and inside is a pump. And so all you need is some LEDs, some strong LEDs, mind you, the stronger the better. A black reservoir, it has to be black or else you grow like, you grow all sorts of crap inside. And then these baskets, these domes, and then these, I don't know what they're called, but they're essentially like wedges. They're like sponges, which the sponges are very, very inexpensive. So here's a 120 pack for 30 bucks, 124 for 18 bucks. Actually, that one has the whole everything included. Wide spectrum LEDs is needed. Yep, absolutely. You can actually just buy grow lights. I've been looking this up for a while. See, they're not very expensive. Obviously, you want more output than most things show. But the point is, it's doable, right? And so, here is what I'm thinking. Come closer and burn. All right, so we get, actually, hold on. Let me make this easier to see. Here, we can put this underneath. And I need, whatever, I can use one of these. Not blue. Not pink. Looking for a good marker. Sure, purple. Okay. So, ESP32. And our options here are either the C3 or S3 Okay. From Recalling was part of the team designing commercial hydroponic systems. Very nice. So ESP32, either C3 or S3. And then the ESP32 has real-time clock plus NTP. So real-time clock is a device that keeps time locally, supposedly with really good accuracy. And then NTP is you connect this network time protocol, you connect to a server and you check the time. You can get away with a cheaper real-time clock if you use NTP, let's say once a day on ESP to sync the clock. So that's the idea. Okay, and then you've got relay 1. Relay 1 would be your pump. So I can use a 12 volt, so I don't have to deal with line voltage. Okay. Relay 2. LEDs. Again, 12 volts, don't have to deal with line voltage. Relay 3. Fan. So the fan, you turn it on. Actually, you can have more than one fan. Whatever. The fan is, you turn it on to blow air across the plants, and they strengthen. And then relay 4, auxiliary. So that could be a second pump, that could be a bubbler, that can be a whatever. So all you really need to do is have your ESP32, check your time, and you want to turn on the pump every half hour and run for a half hour or whatever. Your second relay will do your LEDs. So for LEDs, I have the correct spectrum. I can buy specific LEDs also. I'm not afraid to buy, but I have these, which are grow LEDs. They are not the white spectrum. They are the maybe I should turn on the light. Sorry, flashbang coming. These guys are the red and blue. So they are the correct red spectrum and blue spectrum that you do want for growing, but they're not the ideal. The ideal would have some UV, would have some white. So I'm thinking I would just supplement this with white as well. VSET 12, enter. One and 2. So it's this, right? The red and blue. And it bothers me that these aren't very bright. Mind you, it's under my... Anyway, so I'd use that, and then some of like these daylight white. So I'd have probably, let's say 6 strips of this, as much as I have, and then 2 strips of daylight white. So we'll try to get as much white as possible, as much light as possible in general. Good morning, Locke. So that can be easily controlled under 12 volts. That's good. I even have some like full spectrum, like some daylight balanced high CRI panels that I can use, but then you start generating a lot of heat, and I don't really need the heat. So where would they be? Should be, oh, here. I have these guys. I just don't want to deal with a lot of heat, you know? These are 12 volt as well. Oh, I still have my power supply on here. This will be a little hard to light. Ugh, my eyes. This is like 20 watts. That is a lot of current. But yeah, I do have these. These, by the way, have quadrupled in price since I bought them. So I bought one round of them, and then I bought a second round, and it had doubled in price. And since then, they're doubled in price again. Also have like these things. Like, I have lights, is what I'm trying to say. But I like the idea of having white light as well as the grow lights to try to offer the plants as much spectrum as possible. If I have to buy grow lights, I will buy grow lights, but you can just use these for sure. They just might not be optimal, but it is what it is. So I've got lights, I've got relays, I know I can run ESP32 and power on relays. And honestly, I feel like this can be done in Python. Like, sorry, let me rephrase that. I know this can be done in Python. I feel like I could do this in Python. So that's the idea. We just need to see if the real-time clock, we can get it working. And then NTP, get that working. I mean, with the help of AI, it's like impossible to fail. Because even if I can't figure it out with AI, I've got other people that can help, whatever. So I feel confident that I can just make the board and make it work. So what do I have in terms of real-time clock then? And then we will try to make that work. Oh, my back. That's not great. Got to be careful on my movements because if I move wrong, my back is going to hurt. Also, the ESP32C3 should be powerful enough to do this, which is good. These are not RTC modules. You don't need the real-time clock. I went back and forth with this with AI yesterday, and the real-time clock is a nice backup because the time on the ESP will drift, and when you're calculating like 24 hours, but mind you, you can have it reach the NTP. You can reach the NTP every once in a while to get it to sync. I have debated whether or not to just ditch the real-time clock. But I do have real-time clocks here. Ugh. Use the built-in one and activate NTP. Firmware updates RTC and NTP. Wait, there's a built-in RTC in the ESP? Built into the IDF. What does IDF mean? Integrated Development Field? Ugh. Let's see. Does the ESP32C3 have a built-in RTC? Yes. Not very accurate. 'Use that in your clock firmware. Good enough. How about if it syncs to NTP once every 6 hours or so? Would the drift be minimal? .5 minutes of error. I don't care, actually. Syncing is built in already. No need for external code, but don't you need to connect to the NTP? Or are you saying every time the C3 is connected to the Wi-Fi, it'll sync itself? There is an oscillator on here. $27K and $33K resistors. Just use a combination or a pot. No, that I know. But I do want it to sync. Maybe I'll have it sync once a day, twice a day. Okay, here is the deal. I want to build a hydroponics system. Want the turn the pumps on and off on something like a 30-minute interval. Jesus Christ, I can't type this morning. Interval, and the lights on and off. Something like on for 14 hours, off for 10, or whatever. How often should I sync to NTP, and also how is that done? Once per hour is gold standard for ESP32 projects. Bunch of C++ gobbledygook here. 1 hour sync frequency. Yeah, that's fine. The logic is fine. Okay, so I think we're good. So let's do this. So let's skip the RTC. RTC can be version 2. The point is, if we get this done now, when I send in my boards, the ones we've made already, when I send that in, we're gonna be good. We don't need to mess with anything else. We can send 2 boards, and then I can work on getting this done. Perfect. So let's see here. I do have opto isolators somewhere, because I do want to run relays. Big fan of relays. Oh, yes! I wanted to buy SMD opto isolators, and I didn't know if I did or not. I did buy them. That is awesome. Okay. So let's prototype a circuit, make sure it works, and then we will make a board. That's our plan for the day, guys. Buckle in. We are being productive. Like so, like so. Oh, okie dokie. I have to go get the diagram for this. We will use our ESP32C3. Let's move this up a little bit. Pin 1, up over to the side. There we go. So opto isolator. That should be all I need, plus a relay. I just want to make sure that we can actually flip on the relay. What else do we have? RTC plus NTP. Okay, that's scope creep. RTC will be for another day. So basically, it's a 4 relay ESP32 board. And then that's it. The only thing is that I'm a little, like, the relay for the pump could be really cool if it was AC. No 1 microfarad ceramic cap. You still have, that's how everything happens. I have a workshop completely filled with components, but every single time I want to start a new project, I have to order new components. Every time. Every single time. There's not a single project that I don't need new components for. Okay, this guy, And then let's grab a relay. Should have a 5-volt relay in here. Oh, shit's heavy. Five volts. Bias assortments of resistors and caps have most values. I go on tirade every once in a while and just order like a madman just to fill up the workshop. But I stopped doing that recently. Like, I literally have everything I need until I start a project, and then I have nothing I need. But that's a different story. Okay, coil is over here. Are these 0.1 inch spaced? Not really. These are not breadboard friendly. Just gonna flip up this pin. This pin is just the normally closed contact. Just gonna flip it up so it fits in the breadboard. There we go. Close enough. Okay, that's good. All I need to know is if I can flip these relays. Just have thousands of caps except a 105. Wrong way and right way to fill up the shop. Yeah. I mean, I think a lot of the cap requirements are kind of nonsensical. When I'm reading up on like AMS 1117s or whatever, it's always like, yeah, just use whatever. You know what I mean? Like, it's kind of like, just, oh shit, I put away my box, but this is still here. And this is the PC PC817 opto isolator, 12 volt to 5 volt converter. Yes. Actually, that's a good point. These are 5 volts. I shouldn't be using a 5 volt converter. I should be using 12 volts because most of my system is 12 volt. Because essentially, I want this. I want one 12 volt power supply. So I essentially want, AMS 1117 powers ESP32, and then 12 volts powers the AMS, and then 12 volts comes down, and then my transistor, oh, my relay needs to be here. Whatever, I'll draw my relay here. So there's a relay, there's the so essentially I need 12 volts. I need 12 volts. So I don't know why I grabbed the 5 volt relay. Let's jam them back in here. Considering my pump must be 12 volts, no choice. because I don't want to deal with line voltage. And 12 volts is so like ubiquitous, so easy to get. You can find 12 volt switching adapters, high current, low current, anything. You can use power supplies from computers. You use all sorts of stuff. So that's 5 volts. $12 volts. This is what I wanted. I literally thought of that yesterday too. You can get 3.3 volt relays too, but then you have to find a 3.3 volt power supply that's powerful enough. So here we go. SRD 12 volts SLC. These pins are sharp, crisp, sharp, like so. And then these are going into pins 14 and 19. There we go, 14 and 19. Wouldn't use AMS 1117 to drop 7 volts though, not with 260 milliamps load. Why are you getting 260 milliamp load? This should only be like a couple of milliamps. We can probably power this up. I mean, I'm a big fan of switching converters. I can use a switching converter. I have plenty. This is, I don't know, 10 milliamps. Wi-Fi will activate. Do you think that'll be a lot? Let me check the actual power draw. The read-in is nice for course stuff, but not great for 12 volts. Voltage, 12, enter. Oh, this actually reads 30 milliamps. It's actually quite a bit. I have a collection of Woolworths, yeah. Mine will probably have to be a little bit more powerful than a cheap Woolworth because I'm powering pumps, fans, lights, all that kind of stuff. So yeah, actually it's giving me 30 milliamps, 28 milliamps. So that is actually a little bit concerning. It doesn't have to be concerning because I can always do, I like literally have beefy regulators. Can use like one of these guys. You can also use, this is a LM317 with a heatsink. Less efficient. I also have some fixed voltage output ones. You just short two pads, yeah, like this. You short two pads, you get your 3.3 volts. So I can actually just do that. A little bit hard to design into my board. These guys I have soldered onto my boards before. These guys are awesome. Can give this honker a try. Yeah, I have... Oh yeah, they are 12 volt relays. What am I talking about? So, you're right. What am I doing? What would be... C3 is outputting to, let's say, 5 relays at 5 milliamps each. And it with Wi-Fi, and let's say 1.5 inch OLED. I wanted to power it with an external AMS 1117 0.3 volt linear regulator down from 12 volt supply. The 9 volt to use the most, only 2. Uh-huh. 100 milliamps, spikes up to 250. Yeah. Buck converter's fine. Yeah, I can drop 5 volts. Yeah, but with decent airflow. Yeah, so the only problem is the integration of the buck converter into my board. Two, 3 amps. Yeah, I've got a lot of... So I can definitely use this down to 5 volts and use the ESP32's 3.3 volt regulator on board. Can definitely do that. Okay, so that is settled. Can turn off this relay. The only thing I don't like about this solution, like I said, is integrating it into my board. These guys are really nice. Look how tiny these guys are. Does not look that complicated. It needs to be removable. I don't know about that. Is this a buck or a boost? Don't actually know. I think it's a buck. I feel like I'm going to turn this into a module. And maybe I'll have it slotted in because DC buck. Okay, thank you. Thank you, Ham and Cheese 25. Welcome to the stream, by the way. Yeah, I might make this into, like, set this up on pin headers and have this plug in and plug out. Although I don't like the idea of pin headers. Let me think about that. Let me think about that. I think I like the idea of this thing fixed. You just solder a bridge across. I don't like the idea of like soldering this onto my board all willy-nilly. Also, Ham and Cheese, congratulations. You're officially the chosen one. You have chosen to make me hungry. Thanks for that. Okay, so let's move these out of the way. So basically, if I just get 12 volts in, and then this goes to the transistor, and then we can just have the ESP32 power it. That should be plenty good. So the plan should be this. Not the first time you've heard that. So ESP32, that'll have an output pin, NPN, and then here's the coil, and then plus 12 volts to the coil. This to ground. ESP32 also needs to share ground. So that is our plan. So this is the PC817 opto isolator. Here, there's our 12 volts. The coil will have a diode across it, freewheeling diode. Or should that be over here? I don't know, whatever. Having lemon ginseng tea this morning, nice. Got your foo-foo coffee. So this is the operative plan. If this functions, this is the heart of my circuit. So we will, if this works, we're good to go. Essentially, do need to power the ESP somehow. Should we test this? We should test this. We really should test this. So we need to solder the 3.3 volt, which is the second one from the top. This will power, actually, I don't know. I think I'll do 5 volt on this. So we'll have a 5 volt rail, and we'll let the ESP do its own regulation, because I think linear regulation is way better. So I think I'll do 5 volt on this. I think that's the plan. Yeah, no, I know it'll take it, for sure. It's just I'm a little worried that these things might not be clean enough to power the ESP32. Like the internal regulator is cleaner, so 5 volts to let the internal regulator clean it. That also means my board will have access to 3.3 from the ESP for low current, 5 volt at relatively high current, and 12 volt at full chooch, which is not bad. Oh, that's at, oh, my iron is still at 400 C. That was for when we were doing big cables. So we're just going to bridge the contacts here. All right, 3.3 volts, here we come. There we go. 3.3 volts. Let's us power, I still got 12 volt power going from up top. So in plus. These are always awkward to test because they're not, these pads are not really croc clip accepting. And then, oh, here it is. Grab the fluke. If it works, it's got to be a fluke. Love this fluke. Somewhere you guys can see this. So we are looking for, am I an idiot? It went 3.3? I did. What an idiot. Oh, the output's not even on. On. There we go, 3.379. So let's now desolder this and solder it onto the 5.5 or the 5 volt like I meant to do. What an idiot. You guys were watching, you didn't even warn me. By the way, if you're new here, I blame the chat always. Couldn't possibly be my fault, right? There we go. Desoldered. I think I lifted the pad. No, just the ground plane is very, very big, I guess. At least now there's solder on it. Well, that'll do it. Where's Franco? He was on voltage duty today. Yeah. There we go. Okay. In plus, in minus. .054. Oh, you guys can't even see that. Professional YouTuber, folks. .055. That looks good. 35 millivolts of ripple, and at 145 hertz. Now, putting a load on this will probably fix a lot of the ripple. This is no load. This says it can output up to 3 amps. 3 amps is tons. We do not need 3 amps. So yeah, we're going to probably solder this onto some pin headers, fill it with hot glue, and then this will slot right in. The pin headers can't carry that much current anyways, so I wouldn't worry too much about it, but it is what it is. So this will be slotted up, and at the same time we'll have good airflow across the back here to cool it down. So that's good. So let's do, I guess we need to breadboard it. Here, I'll just work up here so you guys can see better. Okay. So let me get the wiring diagram for the PC817. PC817 diagram. Image in new tab, there we go. Okay, so pin 4, so this one goes to pin 3, like so. This is going to go to 12 volts. Okay, and then that one goes to ground. Put it to ground. Not really fussed about the colors. Put it to ground. Now we put a 1K. Let's see, do we have a good output? Ugh, I hate ESPs. Look, the numbers for the pins are on the bottom side. Why do ESPs have to be the dominant force when they're not designed with makers in mind? And I know it's not ESP, it's the makers of the development boards, but still. Keep bumping into a cardboard box. Where did I put my extra ESP? Oh, here it is. Yeah, Franco must be napping. Okay. So I don't even know what GPIOs we can use on the ESP32C3 Super Mini. Let's check it out. 32C3 Super Mini pinout. Okay. Oh my God. Oh, interesting. So, wow, you don't really have that much GPIO. If I want, hang on a sec. Ugh, scratching my leg. What the hell outputs do I use? Okay, how many outputs do I need in earnest? Let's think about this. Lights, pump, fan, auxiliary. Let's say 4. So I want 4 outputs. Any purple. So does that mean like I'll give up sensing essentially? So I don't want to, this is going to be a mostly communications board. So I want to keep I2C, UART, and SPI available. So I go 0, 1, 2, 3, I guess. Most pins are multipurpose. Yeah, I ran into a problem doing that on the RP2040 though. Okay, 0, 1, 2, 3. That's fine. We will do 0, 1, 2, and 3. Can turn off my soldering iron. So over here, grab one of these. Pin 0. I'm going to have it go through a resistor over here. I'll put like a 1K. To the base. Analog pins are the safest. Okay. Oops. Oops. And by the base, I mean to the LED. I'll put a 1K. Do I feel like fishing in there? No. I will. Oh, speaking of fishing. Hang on a sec. Can only do one thing at a time. Ontario has released so Ontario is the province I'm in. I should start from the beginning, right? So I live in Ontario, Canada. My name is Dan. Nice to meet you. Those of you who are new here. Ontario has released its new fishing regulations for 2026, and so I have marked on my calendar what days I'll be able to start fishing. You know what? I'll just use 1.5K. 1.3 or whatever this is. This is an odd value. So what days I'll be able to go fishing in the various zones around me. So I'm pretty excited. So let's see, I need to connect to pin 1. Pin 1. And pin 1. So there we go. Now, this may not actually activate the relay. Just thinking about it, because why? Because why? Because this is a high resistance. May not be enough to turn on the LED in there. We'll see. We will see. Okay. So I'm going to wrap this one back to ground. It's going to be a shared ground. Now I just need to put the ESP's ground to here. Okay, all grounded on the same spot. And now I need to power the ESP from 5 volts and the the other one from 12 volts. Okay, so 12 volts here. So 5 volts, 12 volts are set up. So here comes, this will be VSET 5, enter. This will be 5 volts. And this will be 12 volts, VSET 12, enter. Good. No ice fishing. So when I was way up north, I didn't get to do any ice fishing. Just the time didn't allow, and it was bitterly cold. So no ice fishing then. Give me 1 second. Arduino IDE. And right now the weather has been fluctuating up and down around the 0 mark. We got bitterly cold days, and then we got a couple days above 0. So eventually, yes. But the other thing is I have to buy an auger, and I have sort of spent all my money. So yeah, about that. Other port and board. ESP32, C6, C3. This is it there, and then COM port. So an auger is 200 bucks. I have all the rest of the equipment though. And by equipment, I mean I don't have like a shelter or anything. So it have to be a cold day, but not a windy day. I would love to ice fish, but I mean, it just is what it is. What's the boot? Here's the boot. Okay, COM21. Okay, good. All right. Oops. This IDE, having worked with VS Code a bit, this IDE is actual trash. But here we go. Const pin 0 equals 0. Const, not cost. Const int pin 1 equals 1. Const int pin 2 equals 2. Const int pin 3 equals 3. Auger bit in a good drill, yeah. So that's what I'm looking at, and that's still, you're still talking about here's the one I want. I don't know if it's in stock. So yeah, it's been out of stock for a long time now. So I've got a really powerful drill. This is a 8-inch, which is what I'd want. 41-inch length, which I would like because I don't have to bend over so far. But yeah, out of stock. I mean, it's not free. That's the thing. Okay, like so. Pin mode. Pin 0. Output. Pin mode. Pin. Look at how. Why is this here? Why is this here? Like, honestly, go away. Go away. I want to read what I wrote on top of this. Pin 1. Output. pin mode, pin 2, output, pin mode, pin 3, output. They were like $30. When was that, in the 70s? Shit, it's really expensive. And Vevor is a cheap company. Like, that's not a high quality brand. It's decent, but it's inexpensive mostly. Okay, here we go. Digital write, pin 0, high, I should probably set them all to low. Pin 0, low, digital write, pin 1, low, digital write, pin 2, low, digital write, pin 3, low, pin 1, low, delay 1000. Just take this. And then this goes low, high, low, high, low, high. There we go. Sure. Hey, Adam. I wasn't sure which kind you were, ham and cheese, because wait, what? What? No, 32C3. There we go. Specifically told it ESP32C3. Yes, I wasn't sure what kind of person you were, ham and cheese. Some people are pro cheap but, you know, effective, and some people are anti. Some people say you buy once, cry once. It's whatever. I'm pretty sure this will work. Does it upload it first try? We will see. We will see. Is soggy old England. I would take soggy over freezing. Actually, it's not too bad right now. I have to say, all things being told, it's not horrible. Okay, so I need a ground pin for both, really. We have had some days this year at like -30. For the most part, it's been pretty good. Okay, ground for the 5 volts. Here we go. Here we are. And we need one more ground wire. Come on, one more ground wire. Ouch, stabbed myself on something. Come on, get in there. There's a non-zero chance that I fry all of this. No, I'm not America. I'm in Canada, my friend, buddy, pal. We're backing you guys. Be nice. So -30 Celsius. Yeah. Be nice, because us Canadians are backing the whole Greenland stuff, the Greenland defense. We're on the EU's side with that one. All right, here goes. On. Not working, but I suspect this resistor might be too resistant. I'm gonna try 100 ohms. 100 ohms might be too little. Try 470. Picture of that and awards is funny. I'm not sure. Not sure what you're talking about, but if it's politics, I think we best stay away. It's probably for the best anyways. All right, out with you. In with you. Okay, so 12 volts in to here, then to there, then to here, to ground. That should be working. Grounds are tied. Both power supplies are on. No current on either. First things first, 5 volts, 4.88, close enough. .3 volts on the 3.3 volt rail, also close enough. Looks like the Pin 0 is never going high. See that? 200 millivolts. .800 millivolts on pin 1. .3 volts on pin 3. Sorry, pin 2. And 800 millivolts on... What is going on? Okay, well, we know that 3.3. What if we just connected 3.3? Not enough current. Not enough current to get it on. Oops. Let's see if we do nothing with okay, if we power directly from 3.3, it turns on. What is going on? Sorry, I bumped my mic there. Okay, something is wrong here. What is wrong? Did I mess up my syntax? Don't know. Why isn't my C3 through pins 0 to 3 in my code? 3. Super Mini. There we go. Enjoy. Test it with an LED. I could. Yeah, you're supposed to be monitoring current. What's wrong with you? It can't be cycling too fast because there are literal 1-second delays. Okay, let's go Waveshare's website. Boards, C3. Oh, this is not. That's the 0. C6. Wait, this isn't the wave share. What the hell did I buy? Three Super Mini. Oh, can you fuck off? No, get out of here. Oh, it's 10 star. 10 star? That sure looks like it. Oh wait, there's a plus version. I see. Is this the plus? Yeah, this is the plus. Whatever. Okay, same thing. GPIO 01. We're the same. So I picked the wrong board. Definitely. ESP32C3 dev module. Okay, I picked the wrong board. You messed with the wrong board, bro. Okay, let's turn literally all this shit off. And I'll definitely forget which pins I am crocodile clipped to. Definitely. Like 100% will. Okay, so we just have the wrong, probably pin assignments for the board. Let me connect. Hopefully that worked. Okay. Oh, nope, modifying our code. All right. Another board import. 32C3. I don't know if any of these I did, yeah. AliExpress is not much cheaper. When it comes to larger things being shipped, Amazon is actually cheaper, and it's cheaper on Amazon. Actually, I didn't check if there's any stock from Vevor on Amazon. But Vevor sells directly, and it's usually cheaper than Amazon. No. All the prices are way up because it's ice fishing season. Yeah, Gerald, what's wrong with you? So I don't have that JSON. But I do have Espressive. I do have the Espressive thing, right? Boards. Should have just generic. That's installed. That's installed, and that's installed. So all that is installed. I don't know, we're going to try a different. I'll think about it, Gerald. Just kidding. I think I'm pretty sure Gerald's still a Patreon, so I think he's auto-forgiven. He is. So auto-forgiven. Don't even sweat it. If the church can sell you forgiveness, so can I. There we go. Okay. So let's just start by the basics. Just want to see if pin 0 is toggling. And I can't really tell unless I power it. Oh, that's 12 volts. Yeah, let's not do that. Ground. Okay. Oh my God. Everything is falling. Everything is falling. 0 volts. It's toggling. You guys can just barely see it in the background there. Okay, it is toggling. So let's use the giant resistor. And we will go from here to here. And we'll go from here to here. And then we will power our 12 volt system. So this is ground here. This is power here. Right. Right. Okay, it's not functioning. Okay, what do we got? What do we got here? Okay, we're always dropping 12 volts on here. What does that mean? That is on the top of the coil. We need to not always drop 12 volts here. Okay, not enough current. So let's use our 500 ohms FFS. We might okay, it's trying. It's not enough current. Okay. So what we need is we need a transistor. We need a transistor to power the LED. So that is the problem right now. Okay, so good to know. We need to modify our circuit. The ESP32 is not providing enough current to turn on the LED in the opto-isolator. And so we do need an output transistor. So now our circuit is going to look, so this part, oops, this part is going to be the same. So 12 volts. With a flyback diode. Okay. Then we're going to go to the opto-isolator, like so. Okay, and then this is going to be ground. So the opto-isolator is an LED, which will be drawn like this. Okay. And then we need probably either +5 or +3, doesn't really matter. We'll go here, or 12. I don't know, whatever. So it's plus some voltage. Okay. Then a resistor, something ohms, down to here, and then that'd be like a 2N3904, like so, to ground, and then a resistor, something ohm, and then up, and then ESP32. So we've got some positive. We could make that 12 volts. It doesn't really matter, but it will matter what resistor we put here. So it will power this through this. Transistor will turn on, pull current through here. We're going to have a voltage drop that it's probably better for this not to be 3. This should probably be either 5 or 12. Okay, so, and then that should be enough through here, and it'll switch it. So that's the deal. So essentially, we are making sort of like an isolated Darlington transistor through here. 13 watching, only 3 likes. Yeah, that's okay. People just come here for chilling. So I bet you most of the people that are here are not actively at their keyboards. So I get it. It's PC817. That's a 2N3904, and then this will be like a 1N7001 or something like that. That's the coil of the relay. So here's the question. Here's the reel-to-reel question. I'm going to put a poll since we have a lot of viewers. All right. Vote in the poll, folks. It's completely anonymous. Thanks for the like, Anant. Ham and cheese watching through the mobile, casting to the TV. What's your casting solution? How are you casting it? Chromecast or what? Actually, you guys can enjoy the poll. I will grab some coffee and I will be right back because I am down on coffee. Be right back, folks. I am back. Okay, so the poll seems to say yes. Let's see how many votes we got. 6 votes, 67% yes. So, and one is a throwaway vote. So I think it's pretty safe to say we should prototype it. Copy and paste. There you go. Okay, so, but for prototyping, I'm just going to completely redo this and probably use sensible wires and all that jazz, just because I don't want to get confused and break stuff. Okay, so we're gonna put this all the way down here. Okay, so why the 2N3904? It's because I've got tons of them. Also, I have to turn on one of the power supplies, or else the high pitch searing thing hurts my ears. So the reason I use it is because I have a whole bunch of them. And I also have them in SMD, NMOS, NPN, 3904, right there. So I have them in these tiny little sizes. Been a while since you've seen the magic smoke. Yeah, true. So I've got all sorts of these little SMD things so I can keep the board very compact. And that's the plan. Okay, so I also have them in through hole. Oh, my back is a bit iffy. So I'm gonna be Black Rifle Bold. Be right back, BRB. Okay, first things first, let's actually put a diode across the contacts of the relay, just so we can rule out if it doesn't work. We'll rule out that the relay destroyed the transistor. So there we go. So now the relay has a flyback diode, which is good. And then 3904. This is my stock from like 2016 when I started the YouTube channel. How's it going, Fish Guy? Sorry. What am I reading? A Fish Guy. There we go. I had some issues there. All right, so I'm gonna stuff this guy in here. Don't know which way is gonna be more advantageous, but we're just gonna jam him in there. Pretty sure the base is the middle pin of this guy. Just bought a 17 kilowatt car audio amp. 17 kilowatts, 17 divided by, let's say, nominal 13.5. That is 1,260 amps. So good luck with that. You gotta have some big ass wire. What am I doing? Oh yeah, looking for the diagram of a 2N3905 04. What am I doing? Okay, 2N3904 diagram. I always forget which legs are which. New tab. There we go. Okay. Two aught. Your 100 amp hour lithium battery is going to trip the protection. You can generally only pull like 300 amps from them for like a second or so. You're probably going to trip the protection on your lithium battery. Okay, so emitter to ground. I actually should probably flip it the other way. Okay, emitter to ground. Okay. Base will come up to the ESP. So that one we need a resistor on. So which one is this? Nope, I want this one, 1.3K. What's the brand? You should be able to point the speakers down and then make a hovercraft. There are like DB drag racers, people who essentially car audio to the extreme, and their whole point is more decibels, not actually for music. Limitless lithium. Let me see. Audio. Okay. Battery specs. So 56 amp hours, so it's not this guy. Yeah, I don't see the battery, lithium battery. Let's go to Shake Awake. 13 amp hours, 6 amp hours. 6, 6, 6. Okay, not that. Noli. 30 amp hours, 50 amp hours. Nano series. 27 amp hours, 12, 30 amp hours. I don't see them. Not sure if they sell anymore. Nope. No go. This guy? No data sheet though. But up to 25 kilowatts, it's not quite enough. Because 25 kilowatts, I assume, is peak. $2,000, huh? It must be good for fishing, because see, it's got the bass edition. Why bass? The answer to why bass is because fun. Have you seen the hype on the solid state donut battery? No. Let's check it out. Solid state donut battery. Don't want to watch the announcement. Can you just give me an actual picture? Okay. That's a render. Uh-huh. That's it, huh? This is charging. Did you see it? It's look here. Look at this. Look at this here. It's swelling. Okay. I'm excited for solid state batteries, but I'll be excited when I can get them for the price of lithium batteries now. You know what I mean? Like I am so pro technological advancement, don't get me wrong. But yeah. Gotta be real to real here. Did you not see it? It totally swole. I mean, there's still material science, you know? Like, there's still... Like, at some point, the heat has to go somewhere. It's... A solid-state battery is not like a superconductor. Saying they have not achievement. This guy has wild... Yeah. So I'm not... Like, at the moment, it needs to be commercially viable, and then we'll go for it. 120 ohms. This is 47K. Nope. 460 ohms. I mean, just because it's swole doesn't mean it's not solid state. 10 key ohms, too many. I mean, do you not see capacitors have resonance and stuff like that, like in their solid state? 10K. $600K. That's a lot of K. Vitamin K. $10K. I should probably be putting these away as I'm testing them, right? but you'd be wrong. They're going straight back into this bin. $4.7K. Pull out a 27 or 33K? I might. 1K. We got it. Ladies and gentlemen, we got him. Oh, okay, you're not informed. Okay, I mean, fair enough. That's why this place exists. Okay, so this will be on the negative side. And then we need a positive side. Positivo. At some point, we will find a wire. And let's power this from 12 volts. Give me a second here. Hey, Franco. All right, so we got 12 volts minus, let's say 1.8, 10.2. 2 divided by 1,000 ohms. That's 10 milliamps. We should be good. Okay, so this guy will be powered by the 12 volts. 10 milliamps should be plenty. More of a kip than a nap. 2.5 hour kip. Starting installing on top of being a bass head. I like bass too, but I like pike better. And like the trout, I just don't have a spot for trout fishing. Okay, and now we need to go to pin 0. If you're wondering what we're doing, Franco, oops, I am working on my retirement as a marijuana grower. And by that I mean probably going to be growing, well, I'm going to start with lettuce, because in winter, lettuce is the same price as gold per weight here in Canada. And then after that, I'm going to see if I can move forward to more expensive crops like tomatoes, which are also a small fortune here in Canada. Okay, so this needs to be powered. So we'll grab 12 volts from here and attach it here. And then from here, we need to attach it there. And then we need to go 12 volts to here. Volts to here. Wait. Hang on. This doesn't make sense. This doesn't make sense. Why would I be powering the opto isolator? I've got this totally backwards. I've got this totally backwards. I need the ESP to directly power the opto isolator, and then the opto isolator powers the 2N3904. Okay, so we got plus 12 volts here. And then I have my ESP here. Okay, ESP ESP powers optoisolator. Optoisolator seven. No, that's wrong. I always do this wrong. The load needs to come before. Okay, hang on. 12 volts. Actually, no, this will work, right? Because if this goes to ground, I could put a resistor here, R question mark, and then this to ground. Well, no, it has to go after. Yeah, okay, this is fine. Right, this is fine. I need to put the resistor after. Okay. We are powering relays to make a hydroponic grow system, is the long and short of it. Okay, so 12 volts. Okay, comes down to our optoisolator. And then here we'll have a resistance, let's say to limit that. Here's a resistance, and then here's ground. Hooked onto here will be an NPN transistor. It's a 2N3904. And this thing will also go to ground. And then over here will be the relay coil. So both these at 12 volts. And then here will be the freewheeling diode. So this is our Darlington pair here. What will the isolator do? It will do two things. One, it'll amplify the signal from the ESP. And two, it will protect the ESP from any 12 volt ever coming near it, essentially. It's good practice. It's not needed, but it still is good practice. Okay, so we'll just do this and this. So this is that's the PC817, and then this is a 2N3904. Okay, and now here will be ESP, and this will have to be resistance and then ground. Okay. So this is kept one bass in your life, casting bluegills for pike bait, hooked into a 7-pound largemouth. 7 pound is insane. 7 pound is massive. So, okay, so here we go. ESP to the PC817 with a resistor This will, we'll have to check what value we want. We need to turn on this LED with enough brightness. Let's go actually check how much current we need on this, and we'll do calculations. Then that'll turn on this transistor in the PC817, fed from the 12 volts, and this we'll have to figure out the resistance. We want to keep this at a low current, and then that should activate the base here. We should have a little bit of current. We probably need another resistor here. For a sufficient base current, and then that'll turn on the relay, and we have a freewheeling diode for after. Okay. Yeah, usually it's for mains, but there could be a high enough inductive spike through here. Although it's snubbed here, I just want to be 100% sure ESP doesn't get affected. So let's check on the PC817 datasheet what current we need for full on. So if we come here, screen, PC817 data sheet. ESP is a microcontroller. Here, let me, actually, it's this microcontroller right here. So that's it'll connect to internet, and it will check, ESP stands for espressive. It will check the time, and it's our timer. Basically, it's our timer circuit. Those two resistors on the gate of the second transistor doesn't create a voltage divider. Let me double check. This one. So if you think you've got 12 volts down here, the drop will be 0.7 volts, so you'll have 11 point something here. So no, not a voltage divider because they are in parallel. I will program the ESP. ESP it's a microcontroller to do anything with. So here it is in real life. It's right there. So you do literally anything with them. So here's the ESP. This is the one I chose to go with, but if you have bigger projects, like I like little, compact, makes the boards easier to manage, but these are all ESP32s, except for this. This is ESP8266. It's just a older version. Then you've got, this is the ESPW Room 32s. This is, again, old version. This is a lower cost ESP C212. But again, look how big it is. Don't need it that big. And then this is the big boy, ESP32S3 N16R8. It's got the full complement. It's got a lot of processing power. This thing is very powerful. But yeah, all I'm using is these super mini ESPs. All right, here it goes. What was I looking for now? I got distracted. Here we go. All right, so here's our diagram. It doesn't matter. Absolute maximum. So we want 50 milliamps maximum current. That's cool. Okay, collector, emitter voltage. Oh, this is maximum. Anyways, forward voltage 1.2. Oh, it's low voltage. Oh, that's good. 1.2. Peak forward voltage at 0.5 amps, 3 volts. Reverse current. Output. Transfer characteristics. Collector current. We want a maximum of 30 milliamps. That's okay. So we'll keep that in mind, 30 milliamps maximum. Saturation voltage, 0.1 volts. That's good. So how much current do I need? In the LED? $50 milliamps is maximum. Thank you, ham and cheese. So we probably want to aim for, I don't want to put 20 milliamps. What is the 2C3 maximum current per pin? $40 milliamps, but we don't want that. Under 20 per pin. Total board current, 500. So I probably want to aim for about 10 milliamps. We could do 5 though. Okay, so to calculate, so we got 3.3. 3.3 minus 1.2 equals 2.1. So 2.1, and we want 0.0. Let's go like 8 milliamps. Is it a resistor that takes down the amps but keeps the volts the same? No, they're all, no, sorta, but no. It's all interrelated. So we need a resistance of, let's say, wow, that's a small resistance. What would I get? 2.1 divided by 3.3. Oops, sorry, 330. We get 6 milliamps with a 330 ohm resistor. What do I even have? Because I have these standard sizes. Oh, I have a 220. I have a 220 or a 470. 220 might bring us a little high. .1 divided by, that brings us to almost 10 milliamps. I'm just thinking if I combine some, I am adding more pads, more complexity to the board. What are these little boxes? They are just SMD. These guys. Here, let me get you an affiliate link if you want to buy some. There you go. Yeah, it's essentially ice cube trays, but they're all individually clippable. You can clip them together. They're a little bit more expensive than this, unless you're a first-time buyer, but they're fairly good. I'm gonna pin that there. Where was I? Oh yes. Okay, so 220. Let's check 470. Is 4 milliamps enough? Is 4 to 5 milliamps enough? Because I want to use, I'm going to try 470. So we're going to grab this guy and say 470 ohms. And the other option is 220 ohms. Okay, and then for this one, that doesn't really matter. We want to keep it like this will be low, low, low current. So this one at 1,200 ohms, that'll give us 10 milliamps. But I have 1,000 ohms, so we'll put a 1K here. 1K. And then this one here, I need enough current to drive this. So that could be like it could also be a 1K. Let me check. Screen. Oops. Current gain 40 to 1. What's the maximum gate? Emitter to base voltage, 6 volts. How's it going, Mr. Ireland? Am I making a mistake here? Can I connect my base to 12 volts? 4. No, sorry, that's not what I meant. Sorry, I will have also a 1K resistor on the base. Yeah, okay, we're good, we're good. Two to 4 milliamps, that's okay. Okay, we're good. I don't think so. A MOSFET would maybe be smarter. If I use an NMOS here, it might be smarter because it'll have no base current. Anyways, we'll put a 1K here. I think this will work. I think this will work. Okay, now can I get to prototyping my thing without blowing anything up? So I need to undo all this shit and restart, because for some reason I was thinking wrong. I was thinking that my optoisolator isn't powered enough, so I'd use a transistor to power it, but I should actually just use the ESP to power this, and then this will switch on a transistor, which will then turn on this. So that makes more sense. Okay. Also, I'm very rusty for breadboard circuits. I usually do microcontroller circuits these days. So I am finding this is a mental challenge. You can stop the jokes now about being mentally challenged. Not funny, okay? Okay, so we are going to use either a 470 ohm or a 220 ohm for the optoisolator. Maybe actually the optoisolator would be best served flipped upside down. How's work going, Mr. Ireland? Will that confuse me? Probably. All right, so we need a 470 ohm. Also, I need my coffee. We are not getting this board done today, by the way. I'll see if I'm working tomorrow. If I am not, then I'm going to stream tomorrow morning again. All right, so 470 should be yellow, violet, black, black. So it should be a little bit faster. Here's yellow, violet. Yellow, violet, black, black. I think this is 470. Is my back better? Sorta. Uh, 460, close enough. Close enough for the girl I go out with, which is working right now. And I'm going to end stream at 11, by the way. Today is a day. Oh, it's Sunday. Sorry, I just put my foot in my mouth. Sorry about that, Curtis. So, no, I want to connect directly to this, then this goes to ground. So this goes to ground, like so, and then this pin will go directly here. Actually, it's an LED. It doesn't matter. I keep forgetting. This side is just an LED. It's not a transistor. Doesn't matter what side your load is. So here we go. Close enough for government work. I wish I worked for the government. When I went back to university, that was the idea, and then I got my teaching job. And when I got my teaching job, I couldn't do both. I couldn't work and go to university full time and do my teaching job, so I quit university. I didn't get my degree, and now the teaching job is gone, and I don't have a degree. Thanks for nothing, college. Thanks for nothing, Doug Ford, actually. Stupid Emmer effer. I didn't vote for him. Don't blame me. Anyways, look, so during Christmas break, you lost your site visit bag, digital tape, 3D printed gauges. Oh no. Oh, that sucks. And nobody like reported it? That is horrible. Okay, now I need the diagram, and I shifted this upside down. So PC817. Okay, so 12 volts goes to pin 4. So that's up here. Okay, and then the next pin goes down to a resistor to ground. 1K resistor. So 1K should be brown, black, brown, black, black, brown. Brown, black, black, brown. I think I got one right here. Let's check it. You wouldn't put 12 volt into an opto. Why not? It's just a transistor. I think you can do 12 volts. Okay, let me think about this. Emitter, collector, breakdown voltage. Emitter, collector, that's reverse voltage. I can't think. Can I use the transistor side of my PC817 to switch 12 volt relay coil? Don't worry, I have a flyback diode. Wait, actually, sorry. Sorry, let me rephrase that. Can I use the transistor side of it to power a 1K resistor and a 2N3904 base with 1K base resistor as well, but the catch is that the PC817 will be supplied with 12 volts. Yes. Okay, we're good. Okay. Gemini says I can. I mean, I could have figured it out myself, but I was as I have some brain drain problems. Okay, so now this will, now I need my diagram. Is it touching 12 volts? Yes. It will. but it seems like I should be okay. Okay, so collector, just need to mentally get this correct. So the collector is on this side. Right. So the collector of the transistor will go to the relay coil. Welcome back. I mean, because the thing is, let me be clear. I want to make sure I'm clear. What I'm basing it off of are those Arduino modules. Here. God damn it. I just want to make sure we're on the same page. Also, we are never going to get this done because I keep getting stun locked. Arduino relay. 12 volts. Okay, so if you look at these, so they take 12 volts in. This is a very bad picture. Here. Okay, so they take 12 volts in. It's got some colored small buttons. Cool device to build yourself to learn a little. There we go. Seems quite simple. The dispenser might be a little more complicated. So they take 12 volts in, and then the Arduino directly powers the opto. And then the opto switches 12 volts onto the transistor, and the transistor switches on the relay. So that is my plan. I want to do it all on a PCB. So all these parts will be on my PCB. But I will explain to people that they can just use this. They can. There's no problem. It's just that I'm sponsored by a PCB company, so I get to make these really cool PCBs, and that's that. But as far as I can understand, see, that's a PC817. It takes the power from here, powers an LED. That's it. Actually powers two LEDs, because there's another one here just to show it's working. And then this powers the base of this, and then this switches your relay on, which is essentially what I'm doing here. So I think I'm okay. So I think I'm good. Okay, back to my diagram. Ideally, I'd like to have this working today, so I can do the PCB tomorrow, or something, or whenever I'm whenevering. Okay, so coil to collector. Okay, so 12 volts to coil. 12 volts to coil. Coil to collector. By the way, you guys are good. Don't worry about stun locking me. It happens. It's probably best that we catch problems in the design phase. Okay, so this is done. Oh, we will put our flyback diode. 'cause I ain't no fly back girl. I ain't no fly back girl. I was punished for that No Doubt song by having to cough. There we go. KiCad info has a schematic for the relay module. I actually have, I don't know if you know this, Locke, but I'm kind of a big deal. Obviously, I'm just kidding, but I actually have my own transistor driver, or sorry, relay driver design. Sorry about the dust. But this is a non-opto-isolated version of my transistor driver, and this works perfectly. So I'm just going to replicate, I'm sort of replicating this, but I'm redesigning it to work with an opto-isolator, and that will mean that it's a little bit more tolerant of 3.3 volt systems. Also, if you look here, I've got my buck converter built into this board here. So I have quite a few. Oh, I got to be careful. Look, this capacitor is shorted. Be careful on that. So, yeah, I've done a lot of these things so far. Where can you go for a good guide on each electronic component? If you're talking about basic components, I've got a guide on transistors. But for the most part, Big Clive or, I mean, just look on YouTube, essentially. There's tons of people. Personally, I need to ask more questions than what YouTubers typically cover. So that was my goal when I made the transistor video, was to answer all of the questions. So if you have something that you don't understand after a first watch through, watch it again, and whatever question you have, ask AI. Ask AI or go read Wikipedia, but just Wikipedia is kind of long. AI is kind of right to the point. And tell AI to be brief. But yeah, YouTuber first, because it's a good guide. And then just ask AI. Okay, so emitter to ground. Emitter to ground. 1K ohm resistor. And then we need a 1K ohm resistor from PC817. To base of transistor. So I need another 1K. Should be this one here. This is brown, black. That's not correct. Oh, brown, black, brown. It's backwards. This should be 1K. I'll check it. ChatGPT helps, yeah, for sure. Which video? I have a form down in the description for video requests, by the way. I think it should be there. I check it once in a while. Okay. This is it. Aside from powering it now, we are done. So power will be yellow for 12 volts. And then ground is orange. Here's another ground for orange. And we need one more power, say brown, for 5 volts. Okay, this will be my 5 volt. So 5 volt there. and then ground is over here. I mean, it's the electronics is like the sort of thing where you need to work at it. It's not going to come to you instantly. Okay, ground here. And then power here. Okay, we're going to turn on the 5 volts. We're going to see if it cycles. Not cycling. Like this, and trying to hit the power here. We've only got 2.3 coming in. Something is not right. We only have 2.3 volts on the power. We have 5 volts there. Oh, we're not grounded. We're not grounded. The ESP32 doesn't have its ground connected. So let's remedy that. Turn this off. Looking for a jumper wire, male to male. Male to male. Ground pin to the ground. Let's try that again. Okay, what do we got? Five volts in. That's good. Try to move this aside a little bit. Okay. That should be proper ground. 1K. Okay, let's grab this as a ground. Let's check our pin 0. Pin 0 not cycling. Our 3.3 is working. That's our ground. That's our 5. So 5 is good, 3.3 is good. Now let's see. Our pin 0 should be going right to the PC817. So the thing is, it's not cycling though. So it's 200 millivolts. Let's stay here for a couple seconds. It is not functioning. If we reset. Oh, that just worked. It works, guys. I just reset the micro. Can you guys hear it? Maybe not. You guys can hear it. Okay. Okay, so just to confirm now, pin 0 works, but before I make a catastrophic mistake, we are moving the resistor to pin 1. Still works. Pin 2. And pin 3. Still works. We're good. Okay. Is the timing correct to what you put? It's close enough. It's 1 second on, 3 seconds off. I feel accomplished. Okay, so now we can just go ahead and design the PCB because there's no reason this wouldn't work. Well, we've tested it. It works with the 470 ohm with the two 1Ks. We absolutely crushed it. Let's open KiCad 9, number 9, new project, new folder. Okay, let's do it, Rangers. So I'll work on this a little bit. Let me just see. Screen. What does that power? Yeah, there'll be. Yeah, correct, Gerald. One each for a fan, a light, and a motor, and an auxiliary. So we can do two. Essentially, yeah, what Gerald said. Gerald is correct. Gerald is 100% correct. So let me just design the circuit here. So we need a PC817. Oh, this sure is loading slowly. I don't think it's ever loaded this slowly. That's bad. Okay, PC817. Pop one of these onto here. We need 3 resistors. Resistor small. I used to use this one with the zigzags, but it says US, so no thanks. 1, 2, 3. 2N3904. 904. We need one of these. And I think that's good. Okay, so if we move this guy to here, we put a resistor. Put a resistor here You know what, I'll space it away a little bit. Like that. Like this. No, we're just let me be more clear. I'm just making sure that it's going to work. So now I can design the PCB. The code is all going to be after. I want to know what the peak allowable current is, and the amount of time you can pull that peak current for. And I want to know what the continuous current maximum is. Yeah, this is just to make sure it functions. That's it. That's all I want for now. So where is this resistor going? Down here. This is here. Okay. And then I want like a label, ground. That's ground. Oops. Ground. That's ground. I'm going to take some wires. This is wires, right? Yeah, wires. Wire this guy up. Wire this guy up. And then I want another label. Oh, I need a diode. I forgot my diode. Let's just go with the 2N4001 diode. Oh, 2N4000. Fine. Or is it 1N4000? 1N? No? Okay, just diode. What? It's right there, 4001. Anyways. Oh, and I need my relay. Idiot. Okay, I need my relay. Fujitsu. Okay, this is just a generic relay. Huh, that might be it. That might actually be the pins. Finder. Oh. That could be correct too. Sanyu. Well, anyways, we'll measure it. Right now I just need like like so. Oops. Okay, can we just move this text? K1 like so. Go away. Move this guy like this. Connect like that. Connect like that. Connect like that. Welcome back. Yeah, everything will be 12 volts. The 12 volts will be coming from a 110 volt source, for sure. That is 100%. But it will be on the, by the time it's on the board, it will be rectified. It'll be 12 volts. So my board, I find when you're sharing boards, which I do, I always offer my boards to the community. I find it is a lot safer not to mess with mains power. People are just a little bit unsafe. That should be good there. Now these need to be populated by their own pads. This will be from an ESP32. So I think that's good. So that's a good circuit. So we need to do this 4 times over. Yes, 120 volts, 60 hertz, yeah. So that's number 2. That's number 3. That's number 4. So there's my 4. Those are my 4 output stages. Okay, and now all we need is an ESP. I might add a little bit. Ugh, excuse me. Here, I can show you. I can show you because I have a nice multimeter here. By the way, 5 minutes till the end of the stream because I am hungry. My wife is done. Have a good one, Curtis. Say hi to Lou for me. Give him a nice pat on the head. Here, let me just jam these leads in here. There's 1. There's 2. So there you go. In my workshop today, 121 volts. Canada and the US had the same paradigm. Yes, we do. Same paradigm indeed. Okay, so the other thing is we know these are outputs. Let me just confirm. Mother effer. Stomped on a box again. Let me just confirm. I do want something I haven't tried yet. We'll have to test this. Mains work. Back when I worked with a band, we carried our own 240 volt transformers. Careful, buddy. Gonna get a MOSFET? I'm confused. Okay. Where is this guy? Okay, so these are outputs. That's SPI. Pin 10 is now the only pin that is not SPI, SDA, or UART. Because we're using these four. We have pin 10. Oh, gotcha. Yeah, it's got stuff from yesterday's stream. If you guys want to, if you want to see what's in it, yesterday's stream is all the junk went in there. Wow, I've never worked with this limited amount of pins, by the way. So I have 4 outputs. So pin 10. You could see that pin 10, this diagram of ESP32C3 Super Mini would be unable to be used as an input pin to, oh wait, I'm going to use Wi-Fi to change parameters. Okay, okay, I feel better now. When is the times? Always? Almost, nearly always? I'm trying to stream every morning that I don't work. That may not hold all year, but I'm going to try my best. To change the code's settings. Just going to go here. Oh, wait. Maybe I can just paste. Create content. Agree. Uh-huh. Whatever, should work. My pin count. Make things, fix things. Yeah, kind of that. Hammer. I do equipment reviews. What do I do? I should probably write that down. I should have it. Hold on. Notepad. Okay, what do I do? Equipment reviews. I do 3D printing, and with that, CAD work. I do circuit prototyping. Prototyping. I do PCB design. I do repairs, rarely though these days. Getting stun locked by ADHD like behavior. I drop 3D prints into coffee cup. That was a good one. Typing not a specialty, no. I don't know what else I do. If anybody else has any other, this is jokes there, but for the most part. He has high blood pressure. That's nice. I actually have high blood pressure, so I'm going to tell my doctor that. Okay, so before I go, because we're pretty much done, let me add the ESP32 in here. ESP32 C3. No footprint. Okay. We're going to add this here, and we're going to put a button, a label. Oops, not this one. I'm going to put a label called mode on GP10. And so we're going to remember that it has a mode. Need a nice power supply. Let's say with a 12 volt car amp being repaired, you're able to lower the current on your power supply. You are kind of shit out of luck, because most power supplies will provide you with a maximum of about 30 amps. So here is what I usually recommend. This is a, are you zoomed out? No, you were already zoomed out. This is a read-in. I'm going to try not to short anything here. This is a read-in RD6024. It's very dusty. This takes 65 volts in, so you need a 65 volt DC power supply. Yeah, I also do that. And it'll output a maximum of 24 amps. So if you need something to limit the current but still have decent current, this one works well. It's a little pricey, but this is about the best bang for the buck you're going to get. Now, the problem is, when you want to come and test a little bit more power, you're going to need something else. So I actually, this just so happens because we worked on it yesterday, I so happen to have my lithium battery from my boat just off screen. It's connected via a Anderson power pole, and yesterday I was able to pull over 600 watts out of this thing easily, but essentially I can pull 1200 watts out of it. So if you had a nice big 12 volt 400 amp hour, you know, with a 400 amp BMS, you could do that, but it starts getting expensive. This is probably the best thing I would recommend. So read-in 6024. Let me put you an affiliate link if you want to just take a look, and then I have to go. So read-in RD6024. Actually, they have a 30 amp version. I think it's 6030. Let me just confirm here. Yes, they do have a 30 amp version, which I asked them for, they didn't send it. So there it is. So take a look at that. You'll need a 64, replace pin message. You'll need a 64 volt power supply. So not cheap. Here it is. But it's a beaut. That's probably what I would recommend for people needing high current power supplies. And then you need a 65 volt power supply. You get like a 3000 watt one. There you go, 1500 watts. And then you get the 65 volt version. So kind of expensive, but if you want high current, it is what it is. But all right, I'm gonna take off. If I don't get a text later today that I'm working, I will be live tomorrow morning. If not, we will figure it out. So have a good day, everyone. Thank you for being here, and I'll see you hopefully on the next one.